is you have to look at these programs and judge whether these files will compile correctly or not. I'm just creating a poll here so that you can put your answers here. Okay, so what about the first code? Will it compile? No, why? T is not defined, right? We don't know what is T here. Right? It is just like saying x equals to 10. You cannot do that. You have to declare it's an integer. So what if, okay, what if we include a line here, let's say tape deck T? Will it work then? Now, why not? Now we define T, right? T is an object. T is a variable of type tape deck. So it will work now. Sure. Or are we missing something still? So what we are doing here is we are creating a reference to an object which is T, but we are not allocating any map to it, right? Which we do with the help of your editor. So if you do this, the value of T is actually null. You can print that. You can print the value of T and see what it is. So you cannot access scan, recode or anything else because T doesn't have any memory. So you need to have a line tape deck T equals to new tape deck. So this is the one which is going to create an object and give it a reference T. Okay, what about the second code? Is that correct? So here we have created a new DVD player, right? And your reference is D. D dot can record is set as true. There is no function like that, right? So again, it doesn't compile. So you need to create this function, play DVD inside this DVD player class, right? So none of these codes will compile. Okay. When you try to do this one should all just jumbled up code. Can you just arrange it correctly? Okay, so let's discuss this. How many of you have done? Can you raise your hands? No? Do you need more time? Take. Okay, so let's look at this. You can code it further during our lab session today. So where do you start with? Since it's a Java code, you always have to start with a class, right? So this is your first step, right? Once you have created a class, the next step is, so until last week, we were directly having a main function, but now we have seen that a class has two things, data members and member functions. So you have some data and some function. So what you can place next is any kind of data if you is there. So this becomes your first step. After, so there are two data members defined here, right? So these can come and sit next. So both of these come here. What next? Right, done. There is no other data. Then you can start having your functions. So you can put this function. Is there any other function? You actually have two classes here. Okay. Any other function do we have? This one, right? So you can define your two functions. One is your place near, another is at. And I think that's all. Right. So that's your class drum kit. It has two data and two functions. Next, you can have. I'm just writing it as test class. You can call it test or client. So this is the one where you can have your main function. So next comes your main function. And what do you do inside main? Create an object. Where is that happening? This place. Right? So you create an object here. You see what output you want bang bang, which is in the function place near. So you call this. So you can call d dot place near. So this is the block corresponding to that. So you can put that here. And what next? Hmm. So where are we calling top hat function? Next you can call this. Hmm. Okay, so what we need to set as false is where is it? This one. That. Okay, so let's continue. So today we are going to look at a few more things. So we'll look at this access specifier, which is private. What does that mean? And we'll talk about constructors. So as you can see here, there is this interesting meme that I found out regarding all these properties on internet. So what we are discussing right now, so we haven't discussed inheritance and polymorphism as of now. We are talking, so abstraction we have discussed about. We'll look at encapsulation in a little bit more detail today, right? So encapsulation as it's defined here is like all of us, let's walk together. Now, what does that mean? Right. So till now we said encapsulation is in a class, you have your data and functions together. So that togetherness is captured in encapsulation. But why would you want them to be together is the question. Right. I request you to stop solving this question. You can do it during your lab sessions. Okay. So in order to explain encapsulation further, I would like you to see some videos. I couldn't find something better than this. So just to motivate the idea, and we don't need sound. Okay, so what is happening here? It's a vending machine, right? All of you must have seen. So let's say you want something out of a vending machine, right? You cannot just like take it or put your hand and get it. There is a proper method that you should do it, right? So another example is this. So a similar example, you would have played it sometimes. Right, similar to a vending machine, you have all these items which are protected inside a glass shield. And again, you cannot just like that take them out. So there's a proper method you have to do it. Now, what does this have to do with object-oriented program? So all the items that you see inside here, they are sort of data, right? Whatever data you are having in a class, and the idea is you shouldn't be able to fetch this data just like anything. There should be proper methods. So functions are also called methods. And with the help of functions, you should be able to access this data. Your data should not be openly accessible for security and privacy reasons. See, very much like, let's say when you go to a bank, you want to deposit some money, there is space. Maybe you hand over the money to the cashier, and what after that? Do you go back with the cashier and then see where your money is going? You aren't allowed, right? So there's a function you do. There is an interface money to the cashier, and then it is up to them how things happen. You cannot directly manipulate whatever money bank is having of yours or of somebody else's. Now, how do we put that in a program? And talking from the perspective of object-oriented programming. So So let's go back and try writing a code for this. Let's say the same for a vending machine. And so let's say I'm the one who want to simulate a vending machine. So in this case, it's going to be virtual. A virtual vending machine, let's say, which gives out cans of Coke and Pepsi. But the point is nobody should be able to touch cans just like that. I'm going to create a class. Right. So here I'm going to define what my vending machine looks like. I'm going to have my class machine, and inside this I'm going to put some cans of Cokes. Let's say 100. Also initialize your data members directly like this. And let's say some cans of Pepsi. So 90. That's all. And I say my machine is ready. That's it. So coming back to this. I'm going to compile this. And the moment I compile this, I get this class machine.class, which is my machine, which I say I exported to you. And now you can use this class to create vending machines. So for that, let's create another file. Let's say customer, or you can call it client, whatever you want. Here I'm going to have my main function. Now I need a vending machine. So what should I do? Create an object of type machine. I'm going to create my own machine. I'm as new machine. Right, so it's like I've ordered a vending machine from you, from somebody who created it. So can I do this here? You see, the point is you can write this code for client inside the same file also. You can write it in a different file also. That doesn't matter. Because ultimately when you compile it, the class file will be in the same folder. Okay, so will this code work? Okay, if it is confusing, let me put this together. Will this work? If it will not work, why it will not work? I should have. Where? This. So, okay, so these braces, so both syntax are allowed. You can write them here or you can write them here. It doesn't matter. So both of these are correct syntax. Is there a logical error in this code or some other kind of error? Anybody tried? Is it working? Okay, what if I just print the value of this? Will it work? Will this work? What's wrong here? Why will it not work? We have been doing this, right? Yesterday we created a student class having certain data members. You create an object of type student and you can print whatever are its data members, right? What is the confusion here? So let's try whether it's working or not. So it shows you that there are 100 cans of Coke. Okay, what if I do not print it and I decrease it by 1? Right, I'm just not printing it. If you want, you can print it before and after decreasing and see how this variable is changing. Right, so if you do this, I'm just checking that it's not giving me an error. Right, this code works perfectly well. So what is happening here is you have a class machine and here is a client. So you see virtually what the client is doing, he created a vending machine and it's like he can just like that change these variables. It's like you're just putting a direct hand there and taking away a bottle of Coke. Right. Now the point is that shouldn't be allowed. As we discussed, there should be a proper method or proper mechanism through which you can change this value. So how do we ensure that kind of security that you cannot touch these variables from outside? So there comes the idea of specifiers. So right now, if you look at this Coke and Pepsi, these are declared to be public. Public is by default. So even if you don't write this keyword public, they are public. If they are public, anybody can access them, just like how it is happening right now. Right. So if you run this again, so no problem, you can access this from outside. Now we'll make a small change here and we'll declare it to be private. Can you guess what will happen now? Let's try compiling the code again. And now it gives you an error. Right? It says you cannot touch this data because it is private. So now what should we do if you want to change the value of this? Basically, if you want a bottle of can, you want it to reduce it by 1, you cannot directly do it. The idea is you should pay some money to get it, right? You cannot get it directly. So for that, you can write a method here, which is a function. Let's say void pay money. Right? So this method, if you call this method, it means that you have paid money and inside this, you can decrease the value of this variable Coke, indicating that you have taken 1. And what you should do now is, you cannot directly access Coke. You can access this method am.pay underscore money. Right? Note that this method should be public. By default, it is public. If you make it private, again, it's going to give you an error. So what you really do is you keep your data members, whatever data you have, that is generally kept as private so that nobody can touch it directly. And you have these interfaces and methods to change this data. Guys, I'm feeling disturbed. A lot of you are talking. I can do that. I can just keep speaking and leave. If you want to listen, listen. If you don't want to listen, that's fine. But the point is, some of you want to study at least. It's disturbing to them. So if not, if you don't show respect for me, at least show it for your classmates. I hope you can respect each other, if not us. Can you? Do you respect each other? Can you show me a raise of hands? How many of you do? That's all? So if you do, show that in your actions and maintain silence. Okay, so the idea is you keep your data as private so that you cannot touch that directly. Any outside class cannot touch that directly. You see, whatever is inside this class, any function that can touch this data, that's not a problem. Inside the class, it is all one unit. Outside the class, whatever is private here, other classes cannot touch that. You can only touch those members, those data, those functions which are public. By default, they are public, whether you write it or you don't write it. If you want to make them private, you have to write. Okay, this one point. Okay. So we have written a function pay money here. We have seen it yesterday. How can you write functions in a class? Now, when you write functions in a class, you can actually pass it some arguments. Right? So somebody asked a question that side yesterday. So when we were incrementing marks, right, of two different students yesterday, how do you change? Let's say for one, you want to increase it by 5. For another, you want to increase it by 10. So the idea is just like normal functions, you can pass arguments to these functions also, right? So let's try to do that. So how much does a can of Coke cost? 40. So let's define that. So let's define one more. From now on, I'm going to keep all the data as private. Right? And let's put a price on it as 40. Right? And the point is you should pay this much money, right, if you want a can of Coke. So when you pay money, you indicate how much money you are paying. Let's say it's 10. So this becomes the argument to your function. You take it here. This is the money that you are paying. And now what should we do inside? When should you decrement this value of Coke? Decrementing the value of Coke means you are giving it out to the user. Right? When the money that they have given is greater than or equals to Coke price. Right? In that case, you can do this. Else, you can say insufficient money. And now let's just try to run this. Right? So it says insufficient money. If you pass a different value here, let's say 50. Right? So it doesn't display anything. Basically, it reduces the value of Coke by 1. If you want, you can display a message here and say collect your can, whatever you want. Right? That is one thing. Now, just like these functions can take arguments, they can also return values. Right? So what you might want to return here? The spare money, right? If the user is giving 50 for a can of 40, you can actually return the pending money. So you can make that a return type for this function int. And in this case, what should you return? Can you tell me what should we return? M minus Coke price. Right? And in this case, you should return everything back, right? You shouldn't keep the money. Return M. So now when you call this function, it is now returning something. It is returning an integer back, which is the money you collect back. I'm going to write here. Let's say int spare equals to. And then you can say right. So let's see. Right. So it says collect your spare money 10. Right. So this is an example of how you can write functions in a class. Now, so notice a few things here. So the variables that you are using inside these functions, there are multiple kinds of variables. So this variable Coke underscore price here, it is a data member. The variable Coke is also a data member. And the other variable M that you are using, that is an argument to the function that is passed from outside. Okay. One last topic and then we will stop. Now, one question here is how do you initialize these variables? Right? In this particular case, we have said that there are 100 cans of Coke. Let me remove this for the meantime, just to keep it simple. And we have the price of every Coke bottle. Right? Now, when you are making a machine, right, I might make any number of machines as I want. So let's say I'm making one machine for the airport where I want to have lesser number of cans but with higher price. And let's say I want to make another machine. Let's say this is for a railway station, right? Another machine. So you can create as many as you want, but this one should have larger number of cans, but at a lesser price. So how do we control for that? What do you think will happen in this particular case? So we have two machines, one for airport, one for railway. What is going to be the number of cans in each of them? Right, what we have defined here, which is 100. If you want, you can actually. Okay, so will this work? I want to see how many cans are there here. So can I do this? We have, let's say, for the airport machine, these many cans. Do you think this code will work? How many of you think it will not work? Can you raise your hands? 1, 2, 3, 4. Good. Why it will not work? M underscore airport dot co. This is a private data, right? You cannot access this outside. So in case you try to do that, run this code, it shows you an error, right? You cannot directly access it. So how do we see how many cans are there? You need to write a function for that. So you can write another function here. Let's say void, and you can call it show status of the machine. And here you can say there are these many cans price per unit is since this function is public, you can call this from outside. Right? So if you want to see this data, you cannot directly call this. What you can do is m underscore airport dot show status, and you can say m underscore railway dot show status. Right. So for both the machines, it shows there are 100 cans, 40 is the price per unit. For the second also, 100 cans, 40 is the price. How do we change that now? Let's say for the airport machine, we want to increase the cost. How do we do that? So one idea is you can write a separate function again because you cannot directly change the cost here. So you can write a function here to initialize these variables. You can say, let's say void initialize. If you want, you can use the scanner class to read input inside this function. If you want, you can directly take some arguments. So I'm taking some arguments for now. Let's say number and price. So you call this function and whatever number you pass here will be given to Coke, and whatever price call here will be given to this. Now we want to change the price for the airport machine. You can say airport machine dot initialize, let's say there are 30 bottles with the price being 100 for each bottle. Yes. Sorry. So what you can do is, if you want to give this as an input, instead of taking, so what I'm doing here, I'm taking two arguments to this function. Instead of taking these arguments, you scan the values here, right? Like you did before. So you can read both of these Coke and Coke price as an input. Okay, now one final thing and very important. So there is a very nice way of initializing in object-oriented programming. You see, it is sort of cumbersome that you first create an object and then you call a method which is initialized. So there is an idea of constructor. So as you see here, this particular function that you are calling here, this one over here, this is called a constructor. Constructor means it is the one responsible for initializing an object, right? Now, what if, let's say we remove this. So I'm not initializing anything here. For now, I'm commenting this function. Okay. And since there is no function, I'm removing this. Will this code work now? What do you think will be the number of Coke and the price? So we are not initializing these values, neither are we initializing them here, and we have also removed this function. So what is it going to print? Will it an error? Will it be an error? So you can always experiment and check what happens. So let's see. So by default, it initializes them as 0. Who is doing that? This constructor over here is doing that. Right? So this is called a default constructor. So what you can do is you can actually provide a definition of this constructor yourself. So take a look at this. I'll go up and I am now going to provide the definition of this constructor. You see what I'm doing? I'm creating a function with the same name as the class name. Right? And I'll say that when you call this, you set Coke equals to 10 and let's say price equals to 200. That's all. So now what will happen? The moment it sees this new machine, you have defined this constructor function over here and it will set both of these values. Now this is a very special function. It doesn't have any return time. Right? And it's public. If you write, if you want, you can write public here and it's actually not needed. That's all. So now let's run this. I'm going to continue for some more time, 10 to 15 minutes. Those of you who want to leave, get out. I'm okay if there is lesser strength in my class. It doesn't matter. So you have to do all this in today's lab. If you want to look at it, look at it. If you don't want to look at it, it is fine. You do it on your own during the lab. It shows an error over here. So we don't have a data member called price. Right? So you see it is initialized as 10 and 200. Right? Now the same question remains. What if you want to initialize them with different values? For both of these different machines. Let's say for airport, you wanted to initialize with a different value. For this, you want to initialize it with a different value. Then the idea is you can actually pass arguments to these constructors. So I'm going to create one more here. So that is called a parameterized constructor. So you can create as many of them as you want, but their arguments should differ. So I'm going to say I'm having two value here, which will be taken as an argument. Int x, int y. Your coke will become equals to x, and this will become equals to y. What does this mean now? When you call this constructor, you can actually provide direct values here instead of calling a new function. So you say 10, 56 here. Let's say you say 20, 50 here. Sure. So let me write here. So this is called a default constructor which takes no arguments. So what will happen now when you call this constructor? This function will be called and it will set up both of these values. Right? Now you run this. So this will be initialized to this value. You can actually write as many of these as you want. You can write one more where maybe you can take just one value. Let's say t. I'm just showing you an example. I don't know why would you want to do that. Let's say for a special case where the price is equal to the number of bottles. So you can set it like this. So you can write these constructors with varying number of arguments. You can have 1, 2, 3 if you want 10. And you can write as many of these as you want. So we'll discuss more about this idea next week. It is called overload. Right? Don't worry if something is not clear right now. So you'll be doing this in today's lab, and that time if you have any questions, I'll hand. So we'll take a 5 minutes break. If you have any questions about this, I'll take. Okay, so today's lab for the first half an hour has an interesting team building activity. So try to come early and try not to miss this lab. I hope all of you have formed your teams. You have some idea. Can you raise your hands, those of you who have formed the teams? That's a new problem now. So how do we resolve that? So how many of you have different members? So how many of you have team members whose labs fall in a different slot? See, I think that is 40%. Okay, we'll discuss it during the lab. So maybe for the today's lab, I hope you will find 1 or 2 people, right, who are in the same. Or we'll merge some groups. We'll see what to do about it.